Okay, so in this lesson, we're going to derive the quadratic formula. And remember, to derive the quadratic formula, we have to use the idea of completing the square. So first of all, let's talk about the quadratic equation, the general form of a quadratic equation. The general form of a quadratic equation looks like this: ax squared plus bx plus c equal 0. All right, now we're gonna use the steps to completing the square on this quadratic equation, on this equation right here. So remember, the first step to using completing the square to solve the quadratic equation by completing the square is this. Remember, if the leading coefficient is of x squared is not 1, you divide both sides by that coefficient. All right, so in other words, see this right here, x squared, that variable is a, so I could get that to be a 1. So I'm going to divide both sides by a. So I'm going to go ahead and rewrite this: ax squared plus bx plus c equals 0. So I'm going to divide both sides by a. All right, so now I'm going to write these as 3 separate fractions. So a x squared divided by a plus bx divided by a plus c divided by a equal 0 divided by a. All right, I can simplify a divided by a, which is 1. So that's just x squared plus, and then b divided by ax plus c divided by a equal, and then 0 divided by a is 0. All right, now remember, even though we don't know what this variable represents, this could never have been 0 anyway, because remember, we can't divide by 0, so this couldn't be 0 anyway, because if that was 0, it would not be quadratic. That if a was 0, it would be linear. All right, so one of the stipulations, remember, was that if you have a quadratic equation, a, b, and c could be any real number, but a could never have been 0. Because if a was 0, this would be 0, and you would have linear. Okay, so it's okay to divide by a, because a can never be 0. All right, now remember the next step. Once you get this coefficient to be 1 right here, and it's now 1, you're going to bring all the variables to one side, constants to the other. All the variable terms. So I get I get x squared plus b divided by ax, leave some space, equal, and then I'm going to right now I'm adding c divided by a, so I'm going to subtract c divided by a from both sides. So it'll look like this. And so this is minus c divided by a. All right, so be careful. This is minus now. And remember, the whole point of completing the square is to, at some point, get an expression squared equal a constant. So that's going to be the whole point. So notice that we are going to get that at some point. We will get this, and then I can use the square root property. Okay, so now the next step is where I'm going to complete the square. So I take the coefficient of x, which is b divided by a. So let's go off to the side and do that. I take half of it. So either I divide by 2 or I multiply by half. So since this is a fraction, I'm going to go ahead and multiply by half. Whatever that is, remember, you're going to square it. So b times 1 is b, and then a times 2 is 2a. And now let's square it. B times b is b squared. 2a times 2a, or 2a times 2a. 2 times 2 is 4, right here. 2 times 2 is 4, and then a times a is a squared. So that's 2a times 2a, so 2a squared is 4a squared. All right, so that's what I'm going to add to both sides. So remember, that's doing the square, that's part A, so you can add that to both sides. So I'm going to say plus this to both sides. So plus b squared divided by 4a squared plus b squared divided by 4a squared. All right. Okay, now this right here should now be a perfect square trinomial. So in other words, I can, if I factor this, a perfect square trinomial, these two binomials will be the same. So if I factor this, I'm going to get, all right, so if I factor this, I'm going to get x. All right, now remember what we said earlier, whatever this expression is right here, when you get to this point, before you square, when you get to that point, that's what you're going to put here. So you're going to say plus b divided by 2a. Alright, now let's just check to make sure that this is going to give us this. So let me just show you that you will get this. So watch. So when I rewrite this as x plus b divided by 2a times x plus b divided by 2a, this is right here, and I use a FOIL method, x times x is x squared. The outer x times b divided by 2a is b divided by 2ax. Same thing here, they're identical, so b divided by 2ax. And then the last, b over 2a, b divided by 2a, times itself is b times b is b squared, 2a times 2a is 4a squared. So plus b squared divided by 4a squared. Combining like terms, beyond the inner, since the denominators are the same, b plus b is 2b. So I get x squared plus 2b divided by 2ax plus b squared divided by 4a squared. And then notice that 2b divided by 2a, when I can reduce the 2's, and so I get b divided by ax. So this becomes x squared plus b divided by ax plus b squared over 4a squared, which is, let me go ahead and kind of put them together, which is what this is. See this right here is this. So this right here is correct. Alright, now let's kind of figure out what this is now. Alright, so what makes this challenging is that all these are variables. There aren't any numbers like you had in previous examples. Okay, so now we're going to go off to the side and we have to figure out what this is. So we got to rewrite this as one fraction. See, I have two fractions, so I got to now have one fraction. So I'm going to go off to the side. I'm going to rewrite this right-hand side. So negative c divided by a plus, and then b squared divided by 4a squared. Alright, now notice you got to find the LCD. So the LCD is 4a squared. So every factor you see has to be part of the LCD. So I have an a, I need an a, but there's one here, there are two here, so I actually need two of them, two factors of a. And then for your coefficient, that's the one that's a 4, so you're going to need a 4. Okay, so I'm going to write two fractions with 4a squared as the denominator. Alright, now you're writing equivalent fractions. So b squared divided by 4a squared is equivalent to itself. So this needs to be a b squared. Over here, though, I have an a, I want a 4a squared. So I got to multiply a by 4a to get 4a squared. So a times a is a squared. But what I do to the denominator, I have to do to the numerator. And so now a negative c times 4a becomes a negative 4ac. Okay? Now I can write this as one fraction since the denominators are the same. Since the denominators are the same, and I'm going to go ahead and put this term first. So since the denominators are the same, I can write this as one fraction. So my denominator is going to be 4a squared. So this becomes b squared, positive b squared, minus 4ac. Okay? So that right here is this. So it becomes b squared minus 4ac all over 4a squared. Okay, now I have that expression squared, equal numbers, now I can use the square root property. So I'm going to go ahead and rewrite this side. X plus b divided by 2a squared equal b squared minus 4ac all over 4a squared. So I'm going to take the square root of both sides, just like this, plus or minus though. The square and the square root undo each other, so you have the expression x plus b divided by 2a equal plus or minus. Alright, now I'm going to write this as the square root of the numerator and then the square root of the denominator. So the square root of the numerator is b squared minus 4ac. The square root of the denominator, now let's think about this. See that square root of 4a squared? Square root of 4a squared. The square root of 4 is 2. Let me go ahead and rewrite like this. Square root of 4, square root of a squared. Square root of 4 is 2, and the square root of a squared is just a. So the square root of 4a squared is just 2a. So the denominator is 2a. All right, now I'm going to get x by itself. I'm going to subtract b over 2a from both sides, just like that. And now I'm going to get the combined like terms. This is 0. I'm going to get x equal negative b over 2a plus or minus this. So this right here plus or minus this, plus or minus the square root of b squared minus 4ac all over 2a. Since the numbers are the same, I can write it as one fraction. So it becomes all over 2a is going to be the denominator. So it becomes negative b plus or minus the square root of b squared minus 4ac over 2a. And notice that this right here is the quadratic formula. So remember, quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is how you actually derive a quadratic formula by completing a square. So it's a lot of variables involved, a lot of places you could easily mess up, but at every step of the way, we used these steps. The same steps we used when solving a quadratic equation by completing the square. All right. So that's completing the square. So that should help you understand. That should help you understand where the quadratic formula comes from.